This is Mr. Hardesty. Let's solve the next problem using linear programming. Graph the system of inequalities. Name the coordinates of the vertices of the feasible region. Find the maximum and minimum values of the function for this region. Y plus 3x less than or equal to 4. Y is greater than or equal to negative 3x minus 4. Y less than or equal to 8 plus x. For the function f of xy equals 4y minus 3x. First, we need to graph our system. Our first inequality we'll rewrite by subtracting 3x, as if it were an equation in slope-intercept form, an inequality y less than or equal to negative 3x plus 4. Now we can graph that by plotting the y-intercept at 4, and our slope is negative 3, or negative 3 over 1. We'll go up 3 and over 1 to get another point here, and we'll have graphed our first linear inequality. It's less than or equal to, so we're considering that region that is below. Our next inequality, y greater than or equal to negative 3x minus 4. That's in slope-intercept-like form for an equation, so we can graph that. Negative 4 is our y-intercept, and the slope, negative 3. I'm out of room this way, so I'll count up 3, but then left 1. Up 3, left 1, and so on to represent the slope. We'll connect those points. And again, considering as an inequality, this one says greater than, so those points are coming this direction. We have one more to graph. Y less than or equal to 8 plus x means 8 is our y-intercept, and the slope of this line is 1, the coefficient on x. So we're up 1 and over 1, or down 1 and over 1. And we'll connect those points like so. And again, this is an inequality that says less than. So we were less than, greater than, and less than. Our feasible region would be shaded here. We need to name the coordinates of the vertices of this region. And here they are. This is the point, negative 1, 7. Here's another one. This point is negative 3, 5. And we have no other points, as our graph is shaded off the page and there is no other intersected points here. So we have negative 1, 7 as one of our vertices, and negative 3, 5 as the other. We'll find the maximum and minimum by substituting those into our given function, 4y minus 3x. So this would be 4 times 7 minus 3 times negative 1, as we substitute xy into the function. That will be 28 plus 3, which is 31. We'll do the same for negative 3, 5. 4 times 5 minus 3 times negative 3. 20 plus 9, which is 29. 31 is bigger than 29, meaning our maximum is 31, and it occurs at the point negative 1, 7. Although we can see this calculation to be 29, that is not our minimum value. In fact, our minimum value apparently does not exist. Since our region is unbounded, and there is no point to plug in down at this end to represent where the minimum would be. So we'll say the maximum is 31 at -1, 7, and the minimum has no value.